Good afternoon, everyone. This is Roy Williamson. I'm the Global Head of Sales and Operations for Speakerbus. I'd like to welcome you to our second webinar in the series that we will be running on a regular basis over the coming months. Today's session is around the fast and efficient centralized management for endpoints and private wires using the Speakerbus gateways. This presentation will be provided by my colleague Marco Ornella, who is here with me in London. Just very quickly, I'll touch onto the agenda. You'll be pleased to hear there's not any lengthy Speakerbus intro today. Really, we're going to focus on about obviously maximizing the private line usage and how our gateway can help with that. Introducing gateways into an existing deployment, how we can use the gateways for line interception, and migrating over to Speakerbus endpoints. There'll be regular points and checkpoints throughout the session. We'll be taking some polls. For those of us who joined us in our previous webinar, we take a number of polls. It's useful to get some engagement and feedback on people's views on differing topics, and there'll be opportunity for Q&A at the very end there. So, as you're probably aware, Speakerbus offers a range of physical and virtual endpoints for voice collaboration, be that intercom all the way through to full-blown turrets and soft turrets. The key features and the key elements that we like to focus on is delivering solutions that are highly resilient, high availability, drive compliance within your organization, but moreover, enable you to leverage and maximize the existing infrastructure that you have within your organization, be that through the private wire, be that through the current UC platforms that you have in place. In terms of maximizing private line usage, what we're going to focus on today is share with you how our gateways can be used to help assist in reducing monthly leasing costs by eliminating unprofitable circuits, reducing the need for any specialist skills within your organization, and delivering always-on business continuity. Obviously, reducing the IT hardware footprint and driving greater control through centralized management, and ensuring that you have line coverage across all time zones in a cost-efficient and highly effective manner. So without further ado, I'd like to pass over to my colleague Marco Ornella, who's going to take you through the rest of the session. We hope you enjoy it, and we look forward to seeing you again soon.
Thank you, Roy, and welcome everybody. I'm going to start the webinar with what I believe is an interesting question. Do you think the trading environment is ready to get rid of private wires carriers? So we're just going to launch the first poll, and we're going to give you some time to reply, and then we're going to analyze the results together. Great, so the results are in. I can see that people are cautious about the new technology that are trying to disrupt in the market. I also believe that we are still at early stages of what could potentially become the future of the trading environment. But in order to be ahead of the curve, Speakerbus recently joined forces with Green Key Technologies, giving clients the choice to move away traditional private wires if they wish. So just one note before starting: if you have any questions during the webinar, enter them in the question panel, and I'll answer as many as I can at the end of the session. Okay, so let's see how Speakerbus Gateway can help you or your customer saving monthly recurring costs by leveraging your infrastructure and extending private wires across the WAN. In this example scenario, we have two turret sites, London and Geneva. These are just two example sites, sharing private wires between them. Both sites have line coming in via 2 meg circuit delivered by a provider. Speakerbus Gateway can help reducing dedicated lines between sites and can be deployed also in a non-Speakerbus deployment, independently from what legacy system is in use. By intercepting the incoming line from the carrier, the gateways can be deployed without any configuration changes on the legacy trading system. The physical time slot will then be extended across the WAN using RTP streams, G711, G729, or G723, depending on the available bandwidth, eliminating the need of expensive dedicated international circuit. So let's see a bit more in details what the line interception is. We have two IG330 gateways that we built installed in a back-to-back mode. One gateway will be connected to the carrier by the E1 previously plugged in the legacy trading turret system, while the other gateway will be connected to the trading system again via E1. The private wires will then be shared between the two gateways using SBRTP. SBRTP is a Speakerbus proprietary, high quality and low latency codec based on multicast RTP. From the diagram, you can see that there is also an RTP connection which is used to extend the private wires to the far side by unicast streams. So let's see how quick and easy it is to configure what we just talked about in using iCMS. For those of you who are not familiar with Speakerbus technology, iCMS is a centralized web management application that allows to configure every aspect of the Speakerbus deployment by an intuitive graphical interface. So let's bring our demo iCMS up, log in. Okay. So you can see we already created the two sites that we said before. So we have our London site and our Geneva site. We also pre-configured our core region. A core region in iCMS is a logical part of a network in which devices can communicate using IP multicast. Hence why you're gonna see now, I have all my gateways already registered into iCMS, and just for, just to make life a bit easier, I already renamed them. So we have our carrier gateway, that is the gateway connected obviously directly to the private wires provider. We have our legacy gateway, that is the gateway connected to the legacy trading turret, and then we have our far side gateway. Now the carrier gateway and the legacy gateway, they are in the same London core region. That's why they are going to share multicast between them. So let's have a look how we can deploy private wires using our gateways. So we're going to select our carrier gateway, and you can see this is the channels list. So basically like all the time slot. By the way, both gateways has already the E1 digital trunk enabled to interface toward the outside. So the carrier to the private wires provider, and the legacy one to the central equipment. So you can see again the legacy actually. We're going to actually enable the E1 on the legacy one. So let's go back to our carrier gateway. On our channels, you can see I already added all the private wires to all my time slot. So what I'm going to show you now is how we can add the private wires on our legacy gateway. So we select our gateway, we go back to the channels, and as you can see, there's a list of available time slot, 30 time slot, considering that this is an E1. Yeah, so, sorry, go back to gateway. Here we are. So you can see how easy it is actually to select the private wires that we want to deploy and then add it to the relative time slot. So you can see I'm just dropping private wires on all the channels. Here we are. We're just going to put a couple more. Yeah. And then we're just going to apply. So right now, both gateways, they are using the same multicast address for these 5 private wires that I shared between them. And in a normal scenario, you would obviously fill in all the time slot, but it's just a repetitive actions that I'm not going to show right now. And one more thing that I want to show you is all the voice services that we're actually deploying on the gateway right now. They were previously configured over here. What we've done, each of them, they've been provisioned on both core region. So they are available both on our London side and on the Geneva side. So based on the diagram that I showed you before, the last things left for us to do is to extend our private wires to the far end, to the Geneva. So we're going back to our gateways, and we select our carrier gateway. Now, we could create a connection on a channel by channel based to the far end, but that would be a bit tedious and quite long. And if you have quite a large number of private wires, that obviously that is going to take some time. So what we introduced in iCMS is the concept of peer gateways. So I can select as my peer the far end side. So by the way, I'm just going to show you before actually peering the gateways together. On the far sides, there are no channels configured on it. So when a peer IG330 gateway is set, any channel configured will automatically be connected between the two. Changes made to any of the gateways will also be pushed to its peer. So let's set the peer on my carrier gateway. I'm going to gateway. I'm going to select my far side gateway as my peer, and I'm just going to apply. So if I now go back to my far side gateway and to my channels, you can see that all the channels be extended across your one. Makes it nice and easy. And if I'm going to remove one channel from one side, it will be automatically removed also from the other one. So this is a nice feature that has been added to make life of the admin, a bit easier when we need to deploy a large number of private wires. So let's go back to our presentation. Now that we configured our gateways, let's see how we can introduce Speakerbus endpoints, being them 708 or ID808, into an existing deployment. The two systems will run in parallel thanks to the line interception mode that we previously configured. These allow us to deploy our endpoints in a phased approach, minimizing risk and allowing a seamless and flexible migration. Speakerbus gateways and endpoints both use SBRTP for private wires delivery within the same core region. And because the SBRTP is already in use between the two gateways that we configured earlier, what is left to do is just assigning the desired private wires to the users. So let's go back to iCMS and have a look on how we can assign private wires to endpoints. Okay, so in iCMS, you can see we have already configured a couple of devices. We have two ID808 and an SC708. They are all part of our London core region. So that means that they can use the same SBRTP previously configured on our two gateways. So I basically just need to, so the first things that we need to do is assigning permission to the user to use those private wires. So there are two ways that we can achieve this. One is on a per user basis. So we can select one user, we're going on voice services, and then we can select one by one each private wires and decide what level of permission we want to assign. But there is a quicker way to actually assign permission to a larger number of users simultaneously. So what we can do is creating a group. So we're going to create a group that we're going to call traders. Yeah. And we're going to assign users to the group that we just created. So we're going to multiple select the users that we want to assign, and we're just going to add a membership to the group. Now, what we have left to do now is to assign permission to the voice services that we want those users to be able to have on their device. So again, we can multiple select some of the private wires, and then we're going to give token listen to the private wires that we previously deployed on our gateways. We're going to do it on the entire barrier. So we can select all the private wires again, token listen. Here we are. So now all the three users that we have configured over here, they all have token listen rights on the private wires. Now you can see again on the voice services, they can see that as a user permission, they're using the group and they have token listen on all of them. So let's go and put some of these private wires on one of the users' profile. So we're going to select our first users, and we're going to bring up our iTurret layout builder. So you can see that building a profile on iCMS is very intuitive. There is a graphical representation of a turret, and it's very intuitive on how to create profiles. For example, I created already few of the functions available. So I have an index button that is basically like a shortcut to one of the other pages available on the turret. By the way, the turret supports 100 pages with over 600 programmable buttons in total. So I'm going to bring up my private wires page, and I'm just going to go on an empty key, and I'm going to start to drop some private wires on some voice services, as we call it in iCMS, on the available key. So I'm selecting the type of private wires that I want to add. All the private wires previously configured on the gateways, they were MRD. As you can see, the system can support hoods and audio feeds, so basically like TV feeds through analog gateways, ARD and MRD that are the main type of private wires available around anyway. So we select the MRD, and now I have the list of all the private wires that these users has access to. So I can select the one that I want to leave on the key. Just gonna press OK, and then this is again, I can put on these devices many private wires as I want. Voice service appearance again, another MRD, and then I can just drop in another one. So you can see that over here we already have some speaker channels. So what we can do, we can actually pre-assign some of the private wires that the users has access to a speaker channel, or we can let the users select what private wires they want to have on monitor once they log in on their device. And once we actually created a profile, if the profile is the same for an entire desk or for a larger number of users, what we can do, we can actually turn this profile into a template, and then we can assign these templates to multiple users. Again, these are like nice little touch on iCMS that helps the administrator obviously to manage their estate in a faster and more efficient way, rather than going on user by users and redoing the entire permission stuff. So I'm going to go back to my presentation. Yeah, and okay, we're going to introduce one more poll. I think I skipped one slide, but we're going to launch. Before moving on to the next scenario, we just have one other questions. Do you or your clients have resiliency for private wires? Give you some time again to answer, and then we can move on. Okay, the results are in. I would say that in general, it seems that the majority of you actually do care about resiliency on private wires, and I think that this shows how critical private wires are still in the market. So a good level of resiliency, it's always a nice addition on a system that a company invests in. So let's move on the presentation. Okay, so we now introduce all our gateways, and we slowly phased out. We all introduce all our endpoints, and we slowly phased out the legacy system. So we are now left with the spare gateway. So the one that was previously connected to the legacy trading system. I'm just going to bring up my pointer again. So this gateway was previously attached to the legacy system. It's now, it's now spare. In the next demo, we will reconfigure this gateway to become the active standby for our main one. Speakerbus gateways support automatic failover to offer high availability. And once the two gateways are paired, a heartbeat will constantly monitor the status. In the event of the main gateways being unreachable, the system will fail over to the backup one. to stop these in iCMS is extremely easy. So I'm going to bring back my iCMS system and I'm going to show you how to set up a failover on our gateway. Okay, so we're going back to our gateways. So what we called before legacy gateway, we're going to rename it into backup gateway. And before being able to use these gateways in a failover mode, we will have to delete all the channels previously configured. Now, there are two ways to do it. We can delete one by one the channels manually, or quicker way is to go on gateway, disable our E1, and you can see I'll have a warning that's saying the change in the digital trunk type will delete the device, channels, and connection. So I'm going to say yes. And you can see that all my channels has now been deleted. So I'm now going to my carrier gateway. That is my main gateway with all my channels configured. That is still paired, by the way, with the far side. But I'm now going to introduce a level of resiliency to this gateway. So I'm going on the redundancy tab. I'm going to select backup gateways. That is the gateway that I want to use for backup. Now, the reason why I can only pick one, even if I have 3 configured, is because the gateway needs to be on the same core region. Also, if you want to give resiliency on the E1, we have a pass-through port connection in front of the gateway that allows to share in a passive mode even the physical connection of on the E1 side as well. So now that I have my backup gateway set, I'm just going to apply. And you can see that now the 2 gateways are now linked between each other. So I have primary and a backup. The reason why the system is actually failed already, as you can see, I'm not really using any physical devices for my demo. So everything that is actually configured is on a VM with no physical devices attached. So the 2 gateways are actually trying to ping each other. And because the backup detected that the primary is not responding, he automatically elevated himself as the primary one. But you can see that they are linked together in a resilient mode. And that's as simple as that. There's really nothing else to do on the gateway to introduce resiliency. So what I'm left now is a gateway paired with my far end. So any changes I do on my channels, they get delivered on the far side via RTP streams, as we mentioned before. And at the same time, this gateway also has a backup pair and a backup gateway set for automatic failover, offering a high availability on all my private wires estate. Now, one thing, we extending the private wires across the WAN using RTP streams. Now, we do have one more options available as well, but it also depends from your network setup. We could potentially use SBRTP, so multicast, to deliver private wires across multiple sites, but that means that your network needs to be able to support multicast routing across the WAN. If, like some of our customer already has, if your network is multicast enabled across the WAN, that means that obviously you will be able to deploy even less physical hardware on site, again saving money on hardware and maintenance cost. So we reached the end of our presentation and our demo. We'll now answer some of the questions you have submitted. So just bear with me for a while I'm actually checking the question that I received. I'm just gonna have a look and then answer them. Okay, so I received some questions. So we're gonna start with to answer some of them. So one of the questions is, what's the maximum number of E1 supported on an IG330? The IG330 support a single E1 connection, but its bigger brother, the IG334, can take up to 4 E1, so basically up to 120 channel on a single device. Another question is around the bandwidth usage on the RTP channel. Now, these obviously depend on the type of codec that you select, but let's assume you're using G711 with the highest possible quality. The bandwidth would be around 100 kilobit per second per channel. There's another question around gateway backup. So how do you backup the gateway configuration? Now, all the gateways, they are centrally managed by iCMS. So the configuration on every device is centralized within the system and within the SQL Server database that sits between it. So obviously, by backing up our database, we're backing up also the gateway configuration, and we also have an automatic maintenance plan that can be set in the system section within iCMS. There's another question that is asking how much latency for keep alive if gateways are in a far data center. Yeah. So the average is around 100 milliseconds. However, this really depends on the network setup and the capability of the network itself. Another question was around the forking of the private wires between the two IG330. I believe that this is referring to when we were showing the line interception mode. The answer is no. The E1 is terminated only on one of the two gateways, and then we use SBRTP to connect to the second gateway. So in essence, we moved the existing E1 connection on the legacy system, we move it to one of our gateway, and then we share those private wires between the two by using SBRTP as we showed earlier. So there is one other question around failover on the E1 side. So I mentioned earlier that we have a pass-through port in front of the gateway. So if the gateways, they're actually deployed basically in the same location and they are physically linked between each other, then obviously we can fail over the E1 side as well. However, if they are on separate location, then the forking of the E1 itself will need to be done on a carrier level. So basically making your E1 delivery white shaped from the carrier, then connect it to both of them, and then enabling automatic failover between gateways. I mean, this could be really interesting in a scenario where you have a dual data center deployment type, and you want to have one set of gateways on your primary data center and the resiliency side on the second data center. So they can still be paired together and then fail over between each other. If there are any more questions, feel free to add it there. If not, I believe I answered all the questions that you guys submitted. So I'm just going to give you a bit more time. Okay, so we have one other question that come in, is about recording on the private wires. So all our endpoints, they have active voice recording. So that means that we send the audio and the CDR directly from the endpoints to the IP-enabled voice recorder. So any private wires in use on a Speakerbus endpoint will be actively recorded. Now we do have the options to exclude some channels from being recorded. So in the example of a TV feed, obviously we don't want to flood our voice recorder and using too much space to record TV feeds. So the TV feed can actually be excluded from the voice recording, and we actually exclude it from iCMS itself and not from the single device. So that doesn't mean that we excluding a channel, but we actually excluding, sorry, we don't excluding a speaker channel, we actually exclude the voice service from being recorded directly from backend. So we have another question around analog private wires. Yeah, so we do have analog gateways available. The IG330 and the 334 that we discussed now, they are actually digital gateways. They support just E1 CAS, but we have the IG114 that can support analog circuit In that case, we do have the 2 and 4 wire options, as well as TV feed, obviously, mainly submitted via analog connections. Great, I think I answered all the questions. Guys, if you have any additional queries, please don't hesitate to contact us using the contact details that I'm going to put on the slides now. So here you are. You have our London, New York, and Singapore office details, depending on which region you are. Please stay up to date with future webinars, news, and events by joining us on LinkedIn and Twitter. Thanks a lot, everybody, and see you at the next webinar.